Okay, hi everyone, and welcome to episode 3 in our ongoing series on how to fix clinical evaluation non-conformities. It's Paul here from Managed Systems. It's my pleasure to take you through this latest instalment of the series, and let's get to it. So, as a reminder, this series is focused on addressing a key problem in achieving success following submission of a clinical evaluation, and that's that non-conformities are actually very common under the MDR, but although it's necessary to ensure that non-conformities are resolved, they can be quite difficult to interpret, and it may not always be clear how to fully address any non-conformities which arise, which in turn can lead to further rounds of review with increased costs, lost time, stress and worry. And this series is intended to help you avoid common reasons for non-conformities. So, episode by episode, we're working through common non-conformities one at a time and digging deep into what they mean and, importantly, how to solve or avoid them in the first place. And where possible, we try to link to general principles for optimal conduct of clinical evaluation. So, this is episode 3, and this time we're going to look at the following non-conformity. It is not clear that systematic search methods have been used for the literature review. So in order to unpack this one, we need to consider what is a systematic search method and what are the components of a systematic search. And then finally, how should systematic search methodology be applied during clinical evaluation? And understanding those areas will help avoid this non-conformity arising. Okay, so we'll begin with the basics. What is a systematic search method? Well, it is a structured and planned approach to finding relevant sources for literature reviews, and in this case we're talking about its application to clinical evaluation. And so from a clinical evaluation perspective, it's relevant in two sectors. It's relevant to the literature search that's conducted for the state of the art, but also of course for the search that needs to be done for the device under evaluation, and ideally they are two separate searches documented and recorded separately. Okay, so a systematic search method applied correctly helps ensure several things. It makes sure that literature searches are conducted according to a validated pre-specified plan. In other words, you're not making it up as you go along. It ensures that literature searchers have considered all relevant factors to ensure full coverage of clinical use of either SOTA devices or the device under evaluation. It helps ensure that searches are reproducible so they can be conducted more than once and result in the same outcome. And they also help to minimise bias and the risk of accidentally excluding relevant sources. And on a very basic level, there are 3 key stages to a systematic literature search. These are the intended purpose, research questions and search terms. So we're just going to go through each of these in turn. The intended purpose places the literature search into context, and it helps form an input to the definition of research questions. So spending time on the intended purpose helps map out the types of patients and conditions that fall under the scope of the search, the context of clinical use, and so on. So it is a vital input to the scope of the literature search, and it also shows traceability to how the device is used and applied in clinical practice. So it is an important, albeit rather basic stage from the perspective of a literature search. But don't skip it. The next stage is to begin crafting research questions. Now there's lots of ways to do this, but ultimately a research question or a set of research questions just reduces what you want to achieve from the search to a list of simple questions, and it's generally preferred that a validated format is used. PICO is one of them. We're going to take a look at PICO in a moment, and it's a good stage to explore and refine the scope of the search. It's very easy to change research questions, much easier than changing search terms, because with search terms you have to rerun a search each time you change it, and that can be quite laboursome, especially if you've already started with inclusion-exclusion screening. Research questions, though, are worth spending time on because they form a vital input to the specific searches that you'll run. So let's have a quick look at one validated method. It's not the only one, but PICO is an important one. So PICO stands for patient, intervention, comparator, and outcome. It's just a way of breaking down the search or the scope of search into these specific stages. So to take an example, it might be that the patients within falling within the intended purpose are patients with osteoarthritis of the hip, who are candidates for total hip replacement surgery. In this case, this example using ceramic on ceramic hip implants. So this sounds like perhaps the subject device is a ceramic on ceramic. A comparator then will be other ways of doing the same thing. So metal on metal hip implants, metal on polyester hip implants, whatever it may be. And then outcomes of interest may include pain VAS and range of motion. And so that's just one way of framing a set of research questions using the PICO system. The next step, of course, is stage 3, which is the actual search terms. And what we've got here is a series of screen grabs just doing an example search on PubMed. If you look towards the bottom, you can see that I've punched in the different searches based on the PICO research questions. So we had osteoarthritis of the hip. Well, if you look at search 18 there, search is just osteoarthritis, which as you'd expect produces a lot of results. I didn't put hip there because we have the word hip in search 19, total hip replacement, or hip arthroplasty, which is another term for hip replacement. And THR is just a compression of total hip replacement. What you want to avoid is repeating the same term over and over again, because what we're going to do in a moment is combine these. And if you have the same word over and over again and you use an AND parameter, it's looking for it multiple times, which is unlikely. So what PubMed allows you to do, this is all within the advanced search, it allows you to begin building a composite search using these very basic ones. So if you click on the 3 dots next to the first search, you can see the option to add query. And then as you move up through the list, you can add with Boolean operators. So in this case, it makes sense to just add it with and then the same for search 20 and the same for search 21. And what that means is because you're combining lots of individual searches that each individually has a lot of results, you're refining it down to just a few results that cover all of those search terms, which in turn are derived from your research questions. And so it ends up looking like this. This is auto-populated by the system in the query box, and then you can hit search and run a composite search. And in this case, it reduced the number of results to 51, and they're very specific. So it's a very powerful way of reducing lots and lots of irrelevant results to a smaller number of very relevant ones. Okay, so that's the basics. There are some other things to consider though within the context of a systematic search. These are database specification, inclusion, exclusion screening, handling of duplicate results, use of filters, and search reproducibility. So we'll just scoot through each of these individually. Database specification, what this basically means is that you need to state in advance in your search protocol which databases you're going to use for the search. These are some examples on screen. PubMed, Google Scholar, Embase, Cochrane, Wiley, there are other ones around, but it's important they are stated in advance. Otherwise, it may be suggestive of bias creeping into the way the search has been conducted. Usually, using a minimum of 2 is the best approach. Inclusion-exclusion screening is where you move from all of the results that are revealed by an individual search and you refine them down just to those that are actually relevant. Once again, an important principle is to have an exclusion screening process with justification mapped out in advance. This eliminates the possibility that you're designing it as you go along so that only favourable results are included. And this is an example on the screen. This is not complete. It's just some of the exclusion reasons that you might consider. So for example, the top one is where if a study was an in vitro study or preclinical or using results from animals rather than humans, it would be excluded under the code E1. And the justification is that oftentimes it's not clear that results from these types of studies will actually transfer to humans. But you can design an exclusion screening process in advance and document it in the search protocol. And then, of course, you have to actually apply it when it comes to screening of results. But this provides a justification then for every excluded result, which is extremely important. Duplicate results are a problem. This is where you get either the same study being found more than once in your search results, or sometimes it's the same data set that's arising in different publications. So sometimes you get complete overlap of data sets, sometimes partial, and it can be quite tricky to determine with certainty whether or not the same data set has been duplicated. There is a very significant risk of this if you choose to include systematic reviews. Now, individually, systematic reviews are, of course, a very powerful source of evidence, but they can be problematic here, where you may get reviews not only that use multiple primary sources, but different reviews will duplicate each other's data sets. It gets very messy, and there is an argument for excluding systematic reviews and just focusing on primary sources for that reason. Other things to look out for are the same authors' names cropping up across different studies, and reference to specific recruitment techniques, or sometimes you get subsidiary publications or daughter publications from major studies such as randomized control trials. So it's just important to map out a tactic in advance for eliminating duplicates. The reason for that is that including duplicate results risk placing undue influence or weighting on the duplicated data because it's arising more than once. Filters. So most of the search databases allow you to use filters, and they're an automated means of slowing down results, theoretically to those that are most relevant. But you need to carefully justify the use of filters. Their quality and reliability is sometimes questionable, and also because different databases have different filters that are available, it leads to variance across different searches, which can be problematic. Perhaps the most appropriate filters to consider are time limits, especially for a state-of-the-art search, and the key to that is in the name. State-of-the-art tends not to arise from 25 years ago when medicine's moved on, and this is probably particularly the case when it comes to software as a medical device, where technology is advancing very quickly, and so it may be correct to actually constrain your searches in time, but again, careful justification is needed. And then reproducibility, it should be possible for another person to rerun the search and obtain the same results. What about this from the perspective of a clinical evaluation? Well, a detailed search protocol is needed for both the SOTA literature review and the literature review for the device under evaluation. You need to document research questions, search terms, exclusions with justifications for each search separately. Carefully consider any filters and justify their use. Remove duplicate results and ensure reproducibility and use of validated methods where possible. So, in summary then, non-conformity number 3, we've covered what a systematic search method is, the components of a systematic search, and how systematic search methodology should be applied during clinical evaluation. As a reminder, Mantra Systems is a clinical evaluation specialist. We have extensive experience across the market completing clinical evaluations for all classes of medical device with a current 100% submission success record. And so feel free to reach out to us if you have any questions about clinical evaluation or you'd like to speak with any of our specialists with regard to your own. And that concludes episode 3 of this non-conformity series. Many thank yous for your kind attention. And if you have any comments or questions, please just